Hello, Algebra Honors. Let's take a look at our day one set of notes for our Unit 8 on quadratics. So first we're going to talk about what exactly is a quadratic function. So remember, a function is mostly we're talking about a relationship between two variables. When we talk about functions, a lot of times we're talking about a graph that's on a coordinate grid. Okay, and so we're going to have probably two different variables. A quadratic function, if you remember from our last unit, things that are quadratic in nature have some exponent squared. So we're going to talk about a quadratic function. It's a function that is written in the form ax squared plus bx plus c. All right, now there are some caveats. A cannot equal 0, because if a equaled 0, then we would just have bx and c, right? So you have to have some number, some coefficient that's not 0 before your x squared. This is also called standard form, and we recognize this as standard form. We're going in descending order of the exponent. All right, so if this is our standard form of a quadratic function, we could think about like the simplest way to look at some quadratic function. We call that the quadratic parent function. So remember, a has to not be 0. It has to be some number. But b and c could be 0, and it would still be a quadratic function. So our simplest would be a function f of x equals x squared. In this case, a is 1. And b and c are both 0. Or we can either say f of x equals x squared, or we can say y equals x squared. Okay, so what does a quadratic function look like? If you were to graph out a quadratic function by coming up with an xy table or something like that, you're going to plug in for if x is 1 here, y would be 1, or f of x would be 1, right? If x is 2, y would be 4. If x is 3, y would be 9, and so on. We would also probably use negative x values as well. So we're going to make things a little bit easier for all of us in the beginning of this function, this unit though, excuse me, because we're going to use Desmos. Desmos is really great for us to graph a quadratic function and look and see what it looks like. All right, before we get into Desmos though, let me just say that anytime you graph a quadratic function, it's going to be a parabola in shape. Parabola. Okay, so that's like a U shape, like this guy. All right, a parabola has symmetry. It is symmetric. And so there will be, for us, a vertical line that divides our parabola into two halves. You can imagine if you folded along that vertical line, your two parts of that function would line up exactly on each other. Okay, that vertical line that we can use to fold in half if we want to, that vertical line is called the axis of symmetry. Okay, we know of other axes that we think about when we're looking at a coordinate grid, right? This horizontal line here is our x-axis, and we have a y-axis always on our coordinate grid as well. Okay, so the axis of symmetry is going to move depending on what our parabola is. Now, if you're given the expression or the whole equation of a quadratic function, then you can actually use this equation to find your axis of symmetry. X equals negative b over 2a. Here's what you want to remember. For us, all of our axes of symmetry are going to be vertical lines. And remember back in the day when we talked about vux or hoi? Vux is a vertical line where x equals some number, right? Hoi would be the horizontal line where y equals some number. So if I tell you x equals, in this case, let's look, 2. X is always 2. Here x is 2, y is 0. Here x is 2, y is 4. Here x is 2, y is 7. So every single time our x value is 2 for that vertical line. So think back to Vux lines. All right, we can use this equation to figure out what our x value is, and therefore what our line of symmetry is. Also, when we have a parabola like this, we're always going to have either a super low point, that is the very lowest point right there, or if our parabola happens to be opening upside down or opening downward, then we would have a maximum high point. The maximum low point, minimum low point, I should say, or maximum high point is always going to be called the vertex. And remember when we had previous geometry units and things like that, looking at a triangle or any other polygon or whatever, any intersection of two lines or line segments, each one of these is a vertex. And we say when there's more than one vertex, we have vertices. When we're using parabolas, we're just going to have one vertex generally in this section of our quadratics unit. All right, so the highest or the lowest point of a parabola is going to be called the vertex. And the axis of symmetry passes through the vertex right here. Our axis of symmetry passes through the vertex. So if I can see it on a graph, I already know that x equals 2 here, right? I can see that that vertex has an ordered pair of, let me make sure I read it, 2, -4. So I know x equals 2, right? If I had to write the line of that vertical line, write the equation of that vertical line, it would be x equals 4. I'm so sorry. It would be x equals 2. It would be x equals 2. I don't know where 4 even came from. X equals 2, because here x equals 2. This ordered pair is 2, -4. The x value is 2, forgive me. Okay, so we can, if we have some sort of an equation, we can always plug in our x value to find the y value in our ordered pair. All right, the y value is going to be whatever you get when you plug in x. So we don't have this equation, so we can't plug it in, but we can see, looking at that graph, that the y value is -4. All right. So another thing that you can find, you can tell all kinds of things by looking at your parabola, right? We can see the line of symmetry. We can see the vertex is either going to be your high point or your low point. The next thing we're going to talk about is we can see the y-intercept. This is just like all of the other things that we have graphed, mostly lines. The y-intercept is the point at which we cross that y-axis. Here's my y-axis right here. So this dot right here, that ordered pair, is going through the y-axis. Now it happens to be at 0, 0, right? So in this case, my y-intercept is going to be 0. Oops, I'm drifting. All right, so from my graph, I can see the y-intercept, but if I had the equation, I would be able to find it if I wanted to, because the c, ax squared plus bx plus c, the c indicates what that y-intercept is. Also, we know that the y-intercept happens when x equals 0. So if I had a whole equation, I could plug in x equals 0, and that would give me the y-intercept. Okay, so y-intercept is where I cross the y-axis. And there should only be one if we have a true function, because we wouldn't want to have more than one point on a vertical line. X-intercepts, though, we can have more than one. So x-intercepts talk about where we are crossing the x-axis. Where are we crossing this horizontal axis? And so I'm going to talk about intercepts usually with ordered pairs. For an x-intercept, I know there's some value for x, and I know the y value has to be 0, because that's how I cross the x-axis. All right, so you can see in this parabola, we have 2 x-intercepts, right? One of our x-intercepts is here at 4, 0. One of our x-intercepts is here at 0, 0. So notice how it says root up there on my graph. Here's the thing, x-intercepts, we can call them x-intercepts, and usually we'll talk about them as an ordered pair, but we can also call them roots, or solutions, or zeros. It's the 0 of the whole function. The y part of the function equals 0, and we are figuring out what is x if that y part is 0. So there are 4 different ways we can talk about our x-intercepts, roots, solutions, and zeros. Okay, again, it's a 0 because the whole function equals 0. F of x equals 0 or y equals 0, and we are figuring out what x value gets us there. All right, so we're going to take a look and use Desmos to graph these 2 different equations. So let me switch over to Desmos. All right, so I've clicked over to Desmos Graphing Calculator, and I've actually already typed in both of our equations that we're going to consider from our notes. The first equation we're looking at is y equals x squared plus 2x minus 5. So I'm going to go ahead and click that on. Whoops. And so now you can see this parabola. if I had to guess, I would say that the axis of symmetry is right here, where x equals -1. Just looking at it, it looks pretty much like that would be the axis of symmetry, right? And so we can calculate that. Remember, we have the formula that we can use to calculate that. Notice that this one, I have y equals x squared plus 2x minus 5. You know, in this case, the a is 1, b is 2, c is -5. So something I want you to see is this parabola is opening up. Okay, Desmos is really great because remember we've talked about the vertex right here. So if I click, sorry, with the correct clicking, if I click on that sort of silver dot that shows up, that is the vertex, -1, -6. I know the x value of my vertex is -1, therefore the line of symmetry is x equals -1, that vertical line. Okay, that's my vertex. The x value is -1 and the y value is -6. Other things that we just looked at and talked about when we were talking about parabolas, we can find the y-intercept, right? There's my y-intercept. This is where I'm crossing the y-axis, right there at -5. Remember, I told you that the y-intercept is going to be your c value. So see how we have right there, -5, that's our c. That's our c, or our y-intercept. Okay, and then also, you can see that that is at 0, -5, if I want to call it an ordered pair. You can see your roots, or your solutions, or your zeros, or your x-intercepts. So each of these is going to be an x-intercept. All right, so here's one of our x-intercepts, or roots, or solutions. This is our other one right here. So you can see by the ordered pair, you can see the x value and the y value. Of course, y is always going to be 0 because it's the 0 of the function. And in this case, look, we have 2 zeros, right? So this is a positive x squared. So we have 1 x squared. A, in this case, is going to be +1. Notice that our parabola is opening up. I'm going to unclick my zeros there. Okay, let's turn that guy off and click on the next guy. First thing you probably notice is this one. Well, first you probably notice it's blue, but also it's opening down. Okay, so I'm going to drag it and move it. Now my vertex is right here at the absolute maximum. So when we were looking at our other vertex, it was the absolute minimum. This is the absolute maximum. It's the highest y value that I can possibly have, the highest value for the function. Again, I can see my y-intercept. It's at 0, 7. And so apparently I can't click on it. 0, 7. And so we expect 7 to be the c in our equation, and it is, right? We have 2 roots, or solutions, or x-intercepts, or zeros. And you can see that one is at -1.5410 and the other is at 4.5410. We could also estimate that our, or actually we could conclusively say that our vertex, our axis of symmetry, is what our vertex shows us. So where x equals 1.5. So the vertical line of x equals 1.5, x equals 1.5, that is going through our vertex, and that is the line of symmetry. So everything on the left of the vertex, and everything on the left of the line of symmetry is going to match up with everything on the right. All right, so tons and tons of things that you can see just by looking at an equation or a graph. I think I hit everything there. I'm going to close out of Desmos again, and I'm going to come back to our notes, and I'm just going to encourage you to mess around in Desmos and plug different things in so that maybe you have 3x squared instead of just 1x squared. Try it with fractions. What happens if you have 1/4 x squared? Look and see if your parabola gets skinnier or wider, if it moves up or down. Just take a look. You already know that your c value is just going to tell you where you're crossing that y-axis. Okay, so the thing is when we look at an equation, we can find some of the things out that we can see by looking at the graph as well, okay? If I look at this equation, if a is greater than 0, if a is positive, then the parabola is going to open up. Open up, sorry, it already says open up or upward, okay? And we know our vertex is going to be, just like this one, it's going to be the minimum value. The minimum value for the function. Okay, we usually are going to say it's the absolute value, the absolute minimum value, just in case there are other things to be looking at later with more complicated functions. Okay, note that if this is y equals x squared plus 2x minus 5, we know a equals 1, b equals 2, and c equals negative 5. So I can see my a is positive, it's greater than 0. Okay, if a is less than 0, like this one, a in the second one, a is less than 0. Forgive me. A equals negative 1, because that's what I can see. B equals 3, and C equals 7. Now, if my A equals negative 1, remember that time our parabola opens down or downward. Okay, the vertex, when we have something that goes downward, the vertex is going to be there. It's going to be the absolute maximum. It's going to be the highest y value we could get. So we're going to say absolute maximum. If you just say it's the maximum, I'll get it. All right, so again, like I was saying, feel free to play around in Desmos. Change the coefficients of each of these terms. Change your C. Look and see what happens. Okay, your width is going to change, your width of your parabola, the direction, whether it's opening up or down. And of course, if you change the C value, you're going to move the location of the y-intercept. So, all right, let's look at our 2 examples on our next slide. So here we have 2 graphs that we're going to analyze. This is graph 1. So we're going to look at the graph and we're going to think again about those important pieces that we have. We have a vertex, we have an axis of symmetry, we have a y intercept, and we have usually an x-intercept or maybe more than one x-intercept. So in this case, we are going to fill in this whole box over here. Okay, if this is my equation, x squared minus 9, that's my function. I know that the a is the coefficient of the x squared term, so a is 1. B is the coefficient of the x term. Do you see one? No, neither do I, so B must be 0. 0 x's there, right? And then C is going to be our constant, negative 9. Don't forget it's negative. Okay, so I should, because C is negative 9, I should find that I'm crossing the y axis right here at negative 9, and I am. That vertex right there, it's at 0, negative 9, right? Okay, I know also, because the x value of that vertex is 0, that my line of symmetry is the y-axis, okay? Okay, I'm just going to pause for a moment and remind you that this is a difference of squares, so we can factor that into x plus 3 times x minus 3. This is going to come in really handy with us when we are trying to figure out our x-intercepts shortly. And I'll probably not be able to resist, and I'll probably sneak preview you into it, but notice that we have a 3 and a negative 3 when we factor, okay? That matters. So let's start looking at everything in this other box over here. A is positive, right? A is just positive 1. Okay, and our graph is opening upward. That's what we expect from our notes from the last page. My axis of symmetry, the equation to find the Vux line, that vertical line, is x equals negative b over 2a. So I'm going to say negative b, negative 0, over 2a, 2 times 1. Now, we know it's nonsensical to say negative 0, right? 0 is neither negative nor positive, so we're going to have 0 over 2, which is 0. Our vertical line, Vux, happens at x equals 0. It's true. This is my line of my axis of symmetry right here. Every time my x is 0, doesn't matter what y is. So my equation for that line is x equals 0. Okay, to find my vertex, I need to find the f of x. I need to find the f of x. So remember, my vertex is going to be at 0 something, right? It's at 0 something because I know any ordered pair is x, y, and I know my x value is 0. Let's figure out what our y value is. Remember, the f of x is the same as the y, right, for the most part? So I'm going to say that the f of x, when x is 0, because that's what we figured out, so I'm going to say the f of 0, negative b over 2a, we just said is 0. So the f of 0 is, what happens if I plug in x equals 0? Well, if x is 0, 0 squared minus 9 is just negative 9. So the f of 0 is negative 9. That's telling you that the output is negative 9 if the input is 0. Is that what our vertex is? Heck yeah, right there. 0, negative 9. So we can see the vertex on our graph, and we can calculate the vertex from our equation. In this case, because my parabola opens up, I know the vertex is the minimum. It's the lowest y value, or the lowest value of the function that we can have. So this vertex is the absolute minimum. All right, let's talk about x-intercepts. I can see using this graph that I have one x-intercept at negative 3, 0. And I have the other x-intercept at positive 3, 0. Okay, so I'm going to say and positive 3, 0 because it's both of them. There are two x-intercepts. Okay, my y-intercept, there should only be one because it's a function, so there should only be one. It is at 0, 9, that ordered pair. So normally when we're saying intercepts, we want an ordered pair. Okay. My domain, if you'll remember, domain is all of the x values I could possibly have when I'm talking about this function. Okay, and you notice that we are continuing on slowly, but we're going to the left forever, right? We can keep going forever, ever, ever, all the way to the left to negative infinity. And if you notice on the other part of the parabola, we can keep going forever, ever, ever, ever to the right and keep always getting our x value bigger. So if we write this with interval notation, it goes from negative infinity to positive infinity. And remember, with interval notation, we have to use parentheses, not brackets, because we can't actually reach infinity. Now, another way that you could say your domain, you could say it's all real numbers. Right, x, so that x is a member of the real number system. Any x is something that I can plug in up here, and I can end up with some value for y. My range, though, if I'm standing here at my origin, and I'm looking for stoppers, basically barriers, looking up and down, I'm going to go up and up and up forever, right? It looks like I can keep going up forever because of that arrowhead. But I do have a barrier right down here at negative 9. That's the smallest y value I can possibly have. So I'm going to say my range is y such that y is greater than or equal to negative 9. Remember how we did that? So it's the set of numbers that are y such that y is greater than or equal to negative 9. And so that's why I'm using curly brackets. Now we can also use interval notation. Sorry for switching up the sides or the order, but my interval notation, I'm going to say the smallest y value I can have is negative 9. Oops, and I can actually have negative 9, right? Negative 9. I can actually have negative 9 because there's a solid dot there. But I go on forever, ever, ever in the y direction to infinity. And again, infinity has to have a parenthesis. Okay, so that is so much information that you can see. Again, my sneak preview, notice how our intercepts for the x-intercepts are negative 3, 0 and 3, 0. Notice how we have a 3 and a negative 3 up there. That might be related, but that's coming up later. Okay, graph number 2. I'm going to go maybe a little bit faster. I'm looking at this and I know A equals 1, yeah, and B equals negative 2, and C equals 1. Okay? So, if I wanted to factor this, I need two numbers. Let's do our little x puzzle. Two numbers that multiply to give me 1, but add up to give me negative 2. And so I'm going to say that that is 2 times negative... nope, hang on. Nope, it's not. It's going to be negative 1 times negative 1. Sorry, forgive me again. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. This is why I actually talk it all out. So my magic number there is going to be negative 1 twice, yeah? So I can rewrite this in factored form as the f of x equals x minus 1 times x minus 1. But there's even a more efficient way. Notice how it's the same exact factor times itself. Well, that's something squared. So the factored form is f of x equals x minus 1 squared. That's it. There's only one binomial that we need. Okay, here we had two binomials. We had two x-intercepts. Here we have one single binomial, one single distinct binomial, and we have one single x-intercept. All right, so let's take a look at our other box over here. A, in this case, is positive, and the graph opens upward, which is what I expect since A is positive. My axis of symmetry, I know that I can find that Vux line by plugging in negative b over 2a. So let's see, what's b? B is negative 2, so I want the negative of negative 2 over 2 times a. A is 1. So this is going to be positive 2 over 2, which is 1. X equals 1. That is the equation for a line, right? It's just a vertical line. And you can see that looks like it's going to go right through the vertex. That is my vertical line of symmetry, yeah? Okay, so my vertex, remember it's always going to be x comma y, because it's a point. And so I know the x part of my vertex is 1. How can I find the y part? Well, I can either look on my graph, or I can plug in x equals 1. F of x equals x squared minus 2x plus 1. Let's plug that in. F of 1, because that's my x, equals x squared, 1 squared, minus 2 times 1, plus 1. I just plugged in 1 any place I had an x. And so I know f of x when x is 1 equals 1 minus 2, negative 1, plus 1 is 0. F of x equals 0. Okay, so f of x, remember that's about the same thing as y, right? So f of x or y, the value of the function is 0. Is that where I think my vertex is? It really is, right? There's my vertex, my minimum, at the point 1, 0. So much information that you're getting, either from your equation or from your graph, okay? So the f of negative b over 2a, I already figured out negative b over 2a is just 1, so I want the f of 1. We calculated it out by plugging in x equals 1. We calculated it out, and we said the f of 1 is 0. So much, right? This is a parabola opening up, so I have an absolute minimum when I'm looking at it. In this case, x-intercepts, there's only one. There's only one place that we even touch that x-axis, right there at our vertex. So there's only one this time. In our last example, we crossed that x-axis twice, and so we had to give two different ordered pairs, negative 3, 0 and 3, 0. In this case, we are hitting that x-axis once, so we have one single x-intercept. And one single y-intercept right here at 0, 1. Okay, I can see that on the graph, or since I figured out that that for a y-intercept we know that the x value is 0, I could always plug in 0 for x. So I have 0 minus 0 plus 1. I know that if x is 0, then the f of 0 is 1. All right, so back to domain. If I'm hanging out on my coordinate grid and I'm looking left and I'm looking right, I'm trying to see, is there any barrier to how far I can go to the left? Nope, I'm going to go all the way to negative infinity. Any barrier to how far I can go to the right? Nope, I'm going to go all the way to positive infinity. So again, we can say all real numbers here, right? AR, N, AR, number sign, whatever, all real numbers. Or we can use our interval notation. We are saying that if we are x, we can go anywhere from negative infinity all the way to positive infinity. Any x in that range is going to be a fair x that I can plug in. Our y value, however, does have some limitations, right? Here I am hanging out on my coordinate grid. The smallest y I can possibly have is y equals 0. Right? So y has to be greater than or equal to 0. Now we normally say y such that y is greater than or equal to 0, and we put it in curly brackets, right? I can have any y, if I plug in enough x's, I'm going to get any y that is 0 or greater. Notice there's no graph down here where y is less than 0, right? Okay, we can also say that our smallest y value is 0. So I can go from, but I can be 0, so I'm going to use square bracket 0, and I go up all the way to infinity. So I use parenthesis. Okay, that is so much, and I'm going to actually stop this video, and we're going to watch the next couple of graphs on our next video. 30 minutes is plenty.